It is often assumed that agents are price takers, and under that assumption two common notions of equilibrium exist: Walrasian, or competitive equilibrium, and its generalization, a price equilibrium with transfers. Broadly speaking, general equilibrium tries to give an understanding of the whole economy using a bottom-up approach, starting with individual markets and agents. Macroeconomics, as developed by the Keynesian economists, focused on a top-down approach, where the analysis starts with larger aggregates, the big picture. Therefore, general equilibrium theory has traditionally been classified as part of macroeconomics. The difference is not as clear as it used to be, since much of modern macroeconomics has emphasized microeconomic foundations, and has constructed general equilibrium models of macroeconomic fluctuations. General equilibrium macroeconomic models usually have a simplified structure that only incorporates a few markets, like a goods market and a financial market. In contrast, general equilibrium models in the microeconomic tradition typically involve a multitude of different goods markets. They are usually complex and require computers to help with numerical solutions. In a market system, the prices and production of all goods, including the price of money and interest, are interrelated. A change in the price of one good, say bread, may affect another price, such as bakers' wages. If bakers don't differ in tastes from others, the demand for bread might be affected by a change in bakers' wages, with a consequent effect on the price of bread. Calculating the equilibrium price of just one good, in theory, requires an analysis that accounts for all of the millions of different goods that are available. The first attempt in neoclassical economics to model prices for a whole economy was made by Ley and Walras. Walras' Elements of Pure Economics provides a succession of models, each taking into account more aspects of a real economy: two commodities, many commodities, production, growth, money. Some think Walras was unsuccessful and that the later models in this series are inconsistent. In particular, Walras's model was a long-run model in which prices of capital goods are the same whether they appear as inputs or outputs, and in which the same rate of profits is earned in all lines of industry. This is inconsistent with the quantities of capital goods being taken as data. But when Walras introduced capital goods in his later models, he took their quantities as given, in arbitrary ratios. In contrast, Kenneth Arrow and Gerard Brew continued to take the initial quantities of capital goods as given, but adopted a short-run model in which the prices of capital goods vary with time and the own rate of interest varies across capital goods. Walras was the first to lay down a research program much followed by 20th-century economists. In particular, the Walrasian agenda included the investigation of when equilibria are unique and stable. Walras Lesson 7 shows neither uniqueness, nor stability, nor even existence of an equilibrium is guaranteed. Walras also proposed a dynamic process by which general equilibrium might be reached, that of the tâtonnement or groping process. The tâtonnement process is a model for investigating stability of equilibria. Prices are announced, perhaps by an auctioneer, and agents state how much of each good they would like to offer, supply, or purchase, demand. No transactions and no production take place at disequilibrium prices. Instead, prices are lowered for goods with positive prices and excess supply. Prices are raised for goods with excess demand. The question for the mathematician is under what conditions such a process will terminate in equilibrium where demand equates to supply for goods with positive prices and demand does not exceed supply for goods with a price of zero. Walras was not able to provide a definitive answer to this question. See unresolved problems in general equilibrium below. In partial equilibrium analysis, the determination of the price of a good is simplified by just looking at the price of one good, and assuming that the prices of all other goods remain constant. The Marshallian theory of supply and demand is an example of partial equilibrium analysis. Partial equilibrium analysis is adequate when the first-order effects of a shift in the demand curve do not shift the supply curve. Anglo-American economists became more interested in general equilibrium in the late 1920s and 1930s after Pirot-Sraffa's demonstration that Marshallian economists cannot account for the forces thought to account for the upward slope of the supply curve for a consumer good. If an industry uses little of the factor of production, a small increase in the output of that industry will not bid the price of that factor up. To a first-order approximation, firms and the industry will experience constant costs, and the industry supply curves will not slope up. If an industry uses an appreciable amount of that factor of production, an increase in the output of that industry will exhibit increasing costs. But such a factor is likely to be used in substitutes for the industry's product, and an increased price of that factor will have effects on the supply of those substitutes. Consequently, Sraffa argued, the first-order effects of a shift in the demand curve of the original industry under these assumptions includes a shift in the supply curve of substitutes for that industry's product, and consequent shifts in the original industry's supply curve. General equilibrium is designed to investigate such interactions between markets. Continental European economists made important advances in the 1930s. Walras proofs of the existence of general equilibrium often were based on the counting of equations and variables. Such arguments are inadequate for nonlinear systems of equations and do not imply that equilibrium prices and quantities cannot be negative, a meaningless solution for his models. The replacement of certain equations by inequalities and the use of more rigorous mathematics improved general equilibrium modeling.